You are a forward with the ball, inside the opposition penalty area. A defender approaches from your left side. The goalkeeper has moved slightly off his line toward the near post. In less than half a second, your brain has to decide whether to shoot for the far corner or pass to the teammate making the overlapping run. But the real reason that decision is reached is more mechanical than it seems. Your eyes started collecting the key information several seconds earlier. Your body has already begun to adjust its balance and the angle of your hips. The choice was not created in the instant you faced the moment. It was assembled from patterns your brain had recognized and motor responses it had prepared in advance. How does this rapid selection process actually function? The brain runs two systems at the same time. One system builds an understanding of the current layout of players and open spaces. The other system readies the specific movements your legs and feet will need to execute. These systems exchange information continuously. They do not pause for slow, deliberate thought. They work with whatever visual data is available in that moment. Research on the quiet eye by Joan Vickers has shown that expert athletes maintain a longer, final, steady gaze on the most relevant part of the scene before they begin their action. This extended fixation gives the brain additional time to extract accurate details about distances, speeds, and angles. Players who break this gaze too soon receive less complete information. Their subsequent decisions become less reliable as a direct result. Think about the sequence that unfolds when you first control the ball near the box. Your initial glance identifies the position and movement of the nearest defender. Your next glance assesses whether the goalkeeper has committed to one side. Another quick look might confirm whether a teammate has entered a dangerous position. Each of these fixations lasts only a few hundred milliseconds. Together, they construct the internal model that triggers either the shooting or passing program. A study by Teoldo and colleagues in 2023 compared decision-making speed between professional and academy players during actual matches. The professionals produced 56% more decisions per game. They also reached those decisions more quickly and with higher success rates. Their perceptual systems had learned to filter out unnecessary details and lock onto the cues that best predict positive outcomes in similar situations. Your brain does not perform a full mathematical analysis of every possible option. It matches the present arrangement of players against a vast library of situations it has encountered before. When the current configuration aligns closely with a stored pattern, it activates the corresponding motor program almost without delay. This matching process explains why the highest quality decisions often feel automatic and obvious, rather than the product of careful weighing of alternatives. What happens to this process when the stakes rise and time pressure intensifies? The brain narrows its attentional focus. It becomes more risk-averse. It tends to select the action that offers the greatest immediate certainty of success given your current body orientation and the space you can actually reach. A simple pass that maintains possession frequently wins the internal competition over a more ambitious shot because the brain registers it as lower risk of immediate failure. This bias operates below the level of conscious awareness. The position of your own body exerts a powerful influence on which option is chosen. When your plant foot and hips are already oriented toward the goal, the motor system gives greater weight to shooting. When your upper body faces the direction of a teammate, the passing action becomes more likely to be selected. These postural signals reach the decision system before the final visual confirmation arrives. They create a bias that shapes the outcome without you noticing the influence. Late in the match, fatigue alters the entire mechanism. The duration of the quiet eye shortens. The brain accepts a lower volume of information in order to conserve limited energy resources. This reduction in data quality is one reason why errant passes and squandered opportunities become more common during the final stages of games. The underlying selection process itself grows less precise. Players can train this system to become more robust. Specific practice activities that constrain time and force repeated rapid recognition of patterns strengthen the links between perception and action. Over hundreds of repetitions, the brain develops richer stores of relevant situations and faster, more stable connections to the correct responses. The quiet eye period becomes both longer and more consistent on the information that matters most. You observe the consequences of this trained mechanism throughout modern professional football. A central midfielder receives the ball under immediate pressure and releases it to the correct foot of a teammate without appearing to look. A fullback in transition identifies the run of an attacker into the channel without turning his head fully. These actions appear instinctive to the observer. They are, in fact, the output of highly developed perceptual cognitive systems that complete their work in well under half a second. The next time you watch a player execute a perfect pass or miss a clear shooting opportunity, consider the real process at work. The brief glance toward the goalkeeper or the subtle shift in shoulder position is not hesitation or indecision. It is the brain gathering the last required piece of information to finalize the action it has already prepared. You are still that forward, standing inside the box with the ball at your feet. The defender is still closing in. The goalkeeper is still adjusting his position. But now you understand the actual mechanism that converts those critical half seconds into either the right choice or the one that gets punished.